Good morning, everybody. This is Team 3's evaluation stage presentation. We will begin today's presentation by talking about the process of conceptual development. The tool we chose to develop our concepts was the morph chart. I believe the morph chart is a very useful tool for developing concepts because it helps us avoid fictitious constraints. There are some solutions that might need explanation, and they're the ones that have been highlighted in the morph chart. The first one you see at top here is a circle and a pivoting arm connected to it. The circle rotates and is a very useful shape to use in this case because in one rotation of the circle, the arm gets pushed forward to grab the bone, and then as the circle keeps rotating past this midpoint, it brings the arm back. The next solution that I would like to explain is the 35-second delay sweep. We felt that this solution was very useful because unlike the constant sweeping arm, if we delay the sweep to just a single sweep, 35 seconds right before the end of the round, that'll require only one sweep, which of course will create less wear on our machine and require less energy. The last solution that I feel needs some explanation is this railing. What makes this railing special is that it works simply on gravity. To begin with, to deploy, the railing's angled down and gets released, and gravity drags it down. It then gets lifted by a motor placed right here to this higher angle where it does the job of sorting and imprisoning Grindelwald. After those two tasks are finished, gravity, the rail gets released and gravity brings it back down. Therefore, we egress Azkaban. Now we'll move on to the concept CADs. Based off the morph charts we saw in the last slide, this is my design that I chose. You can see the solutions that I chose for each of the subsystems. The one I'd like to highlight is the rail that works based on gravity. I feel that's what makes the design special and makes it stand out from the rest. And here on the right, you can see an example of the CAD. Next, we see Josh's design. What makes Josh's design stand out is the use of, instead of using a railing or some sort of scissor arm, he created a push-pull system based on prior art. This system makes it so we don't have to use an arm, which simplifies the process of closing that gap between the start zone and Azkaban. Third, we have Thomas' design. What makes this design key? What's key about this design is the use of the scissor arm. The scissor arm is a very complex system, but it's a system that is useful because it can complete two tasks at once. It can both close the gap by stretching itself from the start zone to Azkaban, and it can also be tilted up to perform the task of imprisoning Grindelwald. Lastly, we have Yao Qing's design. As I spoke before in the morph chart, Yao Qing's design is special because of the circular expel dementia arm. The third stage of our evaluation process is the conceptual evaluation. This consists of our evaluation table. Based on the CADs of each person's CADs that I showed in the last 4 slides, we created some criteria to judge the designs. As you can see over here on the left side. After judging all the designs, Josh's design came out to win by a lot. So our final design will be largely based off this design. So based on Josh's design, we created the final concept, and I'm going to show you some CADs of how the final concept will look. This is how the whole system will look at once it's deployed. You can see the subsystems. Here is the sorting of the Nifflers and the shiny objects. Here is the arm to imprison Grindelwald. Back here, you'll see this extended arm, this extended arm. That'll be how we'll protect the home zone. And this back plate will allow us to push and pull our machine back to the start zone. This is an explanation of how the expel dementia system works. It is a simple hinge that will drop, and on the way towards Azkaban, this hinge will simply go over the bone. But on the way back, the hinge will hit this wall when it's being pulled back. Therefore, the bone will be dragged back with the whole machine. The next subsystem we have is the protect the home zone. This is the beginning state of it. Once the machine gets pushed out to Azkaban, these arms will deploy so that when we pull the machine back, we will clear our home zone of any other team's Dementors or Nifflers. Here's a closer-up view of the sorting mechanism for separating the nifflers and shiny objects. Here is also a close-up view of our imprisoned Grindelwald system. It is a simple arm that will be triggered by a mousetrap with a cup to hold the tennis ball that will make it land in the center of Azkaban. And lastly, here's our egress Azkaban mechanism. There will be a hole in this wall where a string will run to the machine. Once the machine has finished its job in Azkaban, this motor will slowly roll the string back and bring the machine back to the start zone.